In this experiment, we are going to determine the molar mass of an unknown compound. Let's look at some terms so we can understand just how impressive it is that we can do this. First, the definition of a mole. A mole is a chemist's way of quantitating the number of molecules or counting molecules. 1 mole of molecules is 6.02 times 10 to the 23rd molecules. This is Avogadro's number. So mole means 6.02 to the 23rd, just like dozen means 12. Well, you might wonder, why don't chemists just use dozens instead of moles? And the reason why is that molecules are really tiny, so we need a really large number of molecules for the amount of 1 mole to be significant. For example, or to give you an idea what I'm talking about, 1 mole of water molecules occupies about 18 milliliters, and we know about how big that is. So a mole of a substance is an amount that you might actually deal with in the lab. So if that's a mole is a number of molecules. What's a molar mass? Well, molar mass is the mass of that number of molecules. Just like a dozen donuts would have a mass associated with it, a mole of water molecules would have a mass associated with it. And we can use the mass, or the molar mass, to weigh out molecules and know how many we're dealing with. It kind of gives us a conversion factor. Anyway, you may know from the lecture part of the class that to get a molar mass, all you do is add up atomic weights off the periodic table. For example, for water, we would look on the periodic table and add up not the atomic numbers, the atomic weights. We would say 2 times the weight of hydrogen, this is for hydrogen, plus 1 of the mass of atomic weight of oxygen, which is 16, so this is for oxygen, and that gives us 18 for our molar mass, and the units for molar mass are grams per mole. Okay, so it's pretty easy to get a molar mass. The thing is, in lab, we are going to determine the molar mass without knowing the formula. We're not going to know what's in that molecule. And that's really pretty impressive, because the molar mass of a molecule or of a compound tells you how big the molecules are. The bigger the molecule, the greater the molar mass will come out. And we will do that all just with some pretty simple instruments and stuff. Okay, another definition is molecular weight. The molecular weight is really the same thing as the molar mass, except that because it says the word molecular in it, it implies that the substance is molecular, or in other words, it has covalent bonds. So it's kind of a limited definition or a limited description. It doesn't apply to ionic compounds, so it's kind of an old term. We don't use it too much. But our compounds today are all covalent or molecular substances, so we could say that we're determining their molecular weight. The next term is volatile. The reason that it is in here is that our unknowns that you're going to get are liquids, and we will vaporize them to make gases, and our liquids are volatile liquids. They do this very easily. We just warm them up, and by the time they get to 100 degrees, they'll all be 100 degrees Celsius, they'll all be gases. And we need that because in order to do our magic to find their molar mass, we need them to be in the gas phase. We are going to use gas laws, and these equations do not apply to liquids. So there's that definition. let's see. We are going to be using the Kelvin temperature scale. And I know you've seen this before. The Kelvin temperature scale is based at absolute zero. So at 0 Kelvin, there's no molecular motion. Since Kelvin is based at absolute zero, if you have a Kelvin temperature and you double it, the kinetic energy or the movement has doubled of the particles. And that's not true in the Celsius scale. So mathematically, it makes the Kelvin temperature scale work better in the equations. It allows the equations actually to be simpler. So in all gas law equations that you're going to be using, you're going to need to make sure you use Kelvin, an absolute scale. And we'll review that conversion here in a second. The next term is the ideal gas constant. I usually just call it R. R is a number, and it has a whole bunch of units associated with it. I always put this on my tests and stuff so you don't have to memorize it. But the thing is, these units tell you what units to use in the equation. So if you have an equation that has R in it, look to these units to know, to make sure that your pressures and volumes and stuff are in the correct units. It's a constant that's kind of a fudge factor. Well, it's not really a fudge factor. It makes the rest of the equation work. So anyway, we'll use that here in a second. So here's the main equation we're going to use to calculate our molecular weight or molar mass. Let's talk about what each part of this equation is. Of course, this is the molar mass. Really pay attention to units here. It's in grams per mole. M is for mass, and it will be in grams. R is that gas constant. With all of its units. T is temperature. And it must be in Kelvin. V is for volume, and it must be in liters. And then P is for gas pressure, and we must use atmospheres.